So yeah, the title of our talk is RxJS in TweetDeck. I'm Amy.
And I'm Guillaume, and we're both engineers on the TweetDeck team.
This is our wonderful team. There's quite a few of them here tonight, so if you see them, be sure to go and say hello and introduce yourselves.
So we are 14 people and 7 men, 7 women, so we got the perfect parity at this point in time.
Yeah, a mix of design, product management, front end and back end. And we actually really like each other on the TweetDeck team, so we do a lot of fun things together. We have Friday morning breakfast at Dishoom, and we have Monday afternoon fika time, which is where we have all the sweet treats. We have too many sweet treats, so we had to batch up all of our birthday and Twitter anniversary celebrations into monthly things because it was just getting out of control.
Yes. And we also love our pets. We've got official Twitter accounts for some of the pets in our team. So let me introduce you Ollie the doggy, who is an account for Ollie, one of the dog of Andreas, one of the engineers on the team, and Moose and Lemon, the birds of Rebecca, one of the designers on TweetDeck. Make sure you follow them.
Definitely follow them. And we also do a lot to support women in tech. So we teach girls to code through an organization called Code First Girls. And we also run workshops for high school students from schools of different faiths. So if you are keen to do more in this space, feel free to reach out to Code First Girls and get in touch.
Okay, so what is TweetDeck? Has anybody never heard of TweetDeck here before? Okay, just a few of you, that's cool. So TweetDeck is a web-based client for Twitter. It's an official client, it's owned by Twitter. And it's a tool that is tailored to meet professional needs. It allows you to do advanced things that you can't necessarily do with a regular web client.
Yeah, and so we said we're going to talk to you about RxJS in TweetDeck, but we wanted to start by telling you what RxJS actually is, for those of you in the audience who maybe have never heard of it. So it's what's called a reactive programming library for JavaScript. We'll come back to more on reactive programming a little later in the talk, but it's as simple as npm install RxJS to get up and running. It's part of a broader library called reactive extensions, and this library is available in many different languages, like you've got RxJava and Rx.net, so it can be used on the front end and the back end to solve many problems. And Guillaume and I are going to start by talking you through one of the problems that it's helped us solve at TweetDeck, which is feature flagging.
So at TweetDeck, we've got tons of features, but we don't always ship all these features to all our user base at once. Usually what we do is we progressively deploy to some of our users. For example, first we deploy to, let's say, TweetDeck team users, and then Twitter employees. And the way we do that, if we use feature flagging, that is, we make a request to a server to know whether the feature should be enabled or not on the client. So this is like very simple pseudocode of the way we would do that without RxJS. So we import a function called setMyFeature that is going to activate or deactivate the feature. Then we make a call to the API endpoint with fetch that returns JSON. Then from the JSON feed, we just pick specifically the feature you're interested in. And so let's say my feature is associated with a Boolean. Then you just pass this Boolean to the setMyFeature function to enable or disable this particular feature. Yes, so it's cool, but the thing is, we've noticed that our users are using TweetDeck for a long period of time. They just leave it open in their browser for hours, days, weeks. So, the features have to be in sync all the time. That is, if a feature is enabled or disabled, it has to reflect on the client immediately. So we can't really rely on the code I've shown you before, because this code would just, if it's just called once at, let's say, initialization, then it wouldn't change during all the lifetime of the application when it's open in one of the browser tabs. So the other thing is, if this code is open in several places at the same time, you can potentially make a lot of useless code, useless calls to the API endpoint, but results in a useless server load. So the way we solve that is by using RxJS.
Yeah, so fortunately, yeah, as Guillaume just said, this is a problem that RxJS can solve. So we're going to use RxJS firstly to tell us when our feature should be on and when it should be off. And then we're also going to use RxJS to make sure that our UI reacts accordingly to that state. So here's how we do it. Here's some code. So we start by creating what's called an observable. Now you can think of an observable as like a stream of values that are being emitted over time. In this instance, what we're doing is we're creating an observable that's going to emit a value every second. That value starts at 0 and it's going to increment by 1 each time. So if we were to visualize this in the console, we'd see something like this. So a value every second incrementing by 1 each time. This value is kind of meaningless to us though, right? What we actually want is the value for our feature flag. Should this feature be on or should it be off right now? So what we can do is we can use the map operator. This is the RxJS map operator, not the regular JavaScript one that you might be familiar with, because it can be performed on an observable. And so what we can do is we can transform each of those values that we were just seeing. So the 0, 1, 2, 3 that we were seeing in the console. We can transform them into what our fetch feature flag value function returns. So those values are going to be transformed into the state of our feature, so whether it should be on or whether it should be off. So if we were to visualize this in the console, instead of seeing the arbitrary numbers, 0, 1, 2, 3, we'd be seeing the value of our feature flag, whether or not it should in fact be on or off. This is a little contrived, so obviously in real life we wouldn't be making this request every second to get the value of the feature flag, and we also wouldn't be changing it so rapidly on the back end. This is purely for demonstration purposes. So from the UI's perspective, the UI doesn't need to know if the feature's on, if it's still on, if it's still on. The UI just needs to know when the feature flag value changes so that it can react to it. So what we can do is we can use this really cool operator called distinct until changed. And what it's going to do is it's going to make sure that the values that are emitted onto our stream will only be emitted if they're different from the previous one. So if we were to go back to the console now, we would only be seeing a true, followed by a false, followed by a true. And then the final step is to subscribe to our observable. And what we do when we subscribe is we attach what's called an observer. We're going to come back to that in a moment. But essentially we're passing in a function that's going to do something every time the status of our feature flag changes. So every time it changes from on or off, we're going to update our state. And as we all know, when we update our state, a render will be triggered. So say, for example, on TweetDeck, we were adding a new column for dogs. If we were to see the impact of this in the UI, say the feature is off, and then we want to turn it on for all the users so it comes back on. And say, for example, there's been a bug, and for whatever reason we need to turn it back off again. We can turn it off again, and all of this can happen without the user needing to refresh the page, which is pretty cool. Okay, so who in the room is wondering what just happened? This is okay. You might be feeling a little confused at this point. So this is totally fine. So all of us on the TweetDeck team, when we first started looking at RxJS and observables, we found them really confusing. And to be honest, even today, when we work with them, we find them challenging at times. So Guillaume and I want to take a moment to recap and walk you through 3 of the key concepts that we just covered. So the first one is the observable. So the observable, as we said, is a stream of values that's being emitted over time. It's a stream of values that's being pushed to us, to the consumer. And the observable can emit one of 3 things. It can emit a regular value, so like the feature flag status that we just saw, but it could also emit a notification that there's been an error, and it could also emit a notification that the stream has actually completed, that there's no more values to be coming down the stream. So we can visualize the observable like a dripping tap. The second key concept, the observer, sounds similar to the observable, but it's different. So the observer is what we attach to our observable when we subscribe to it. The observer keeps watch over the stream. It's watching for those values to come, and it's waiting, ready to react to them. And the observer can have 3 functions. The first function will do something with any ordinary value that's emitted. The second function can do something with an error that's emitted. And the third can do something if a completion signal is emitted. And we like to think of the observer as the dog in this GIF. He's just watching for that ball to come, waiting, ready to react and do something with it. There's this really nice quote from Jafar Hussain from Netflix. Netflix does a lot with RxJS and reactive programming. And he says that reactive programming is like coding when someone's throwing golf balls or events at you. You always need to be ready to react to them. Oh God, no.
Are you ready?
Oh my gosh.
And ready to be reactive?
This is like this is my right hand, yeah. Oh, I got it, yes. I was so worried about that. Okay. So in this quote, the first part of it is talking about the observable, and the second part is talking about the observer.
And the last concept that we only briefly touched on is the operators. I've read somewhere a phrase that really resonated in me is RxJS is actually Lodash for events. And when we think of it, it's like really close to the truth because most of the operators are common to Lodash. So operators are things like we saw map, distinct until change. So these operators, they're used to process the value. You can filter out values. You can change with map value and get the updated value down the stream. You can merge two different event streams into one. Well, there's tons of things you can do. It's really, really powerful. That's where the power of RxJS lays. And this GIF is okay. Anyway, it's
they're
the idea of
transformers.
transforming the value. Yeah. Oops, what happened? Oops. What just happened? Sorry about that. There you go. Up and back. Full screen.
Cool.
Oh, there you go. Cool. So, cool. So now I hope that you've got a better understanding of what RxJS is, and we're going now to take you through more example of where we use RxJS in TweetDeck code base. The first example is the animated tweet engagement. So in TweetDeck, when you click on a particular tweet, you get this view called the detail view, and at the bottom of it. Should be a pointer. At the bottom of it, you've got the what we call tweet engagement. That is the number of retweet, like, replied, and these numbers are live. That means they are incremented automatically as new people are liking, retweeting, and interacting with this tweet. And you can see there's a nice animation where the number is kind of like a ticker, or like a counter, with this little animation. So the way this is implemented is. We've got a component. Let's pretend this is a quote from a component of a detail view. We've got this method called do CSS transition. So what this thing does is first it's responsible for animating this element with like this little ticker animation. Then it returns an observable, and somewhere else in the code, parts can subscribe to this observable and know exactly when the animation has finished, and update the UI or do things with it, whatever it wants to do. So we start this do CSS transition method by caching the DOM element into a counter constant. We then apply the animation. So this is what starts the little animation thing. Then we create an observable that we will return. And what we do in this observable is we actually merge two different observables. The first one is Rx observable from event. And this will create an observable whenever a particular DOM event is emitted. So what happens here is when we add the class ticker animate to this particular DOM element, so I suppose this class has a transition CSS property, and whenever the CSS property, the transition CSS property, so whenever the transition finishes, the event emits this transition end. So what we do here is we just create an observable out of this DOM event. The other observable is a timer that sends an observable every 1 second. So what the merge does really is just take whatever of these two events happen first, just push actually these two events down the line. And the last thing we have to do is the take operator. Take one is essentially we say, whenever there's an event that's coming, we take in the first one, and then the observable is okay to to clean it, tear it down, and remove it nicely. So what is this going to do is this animation complete, this observable is going to emit one event, whichever of the transition end or the 1 second timer happens first. And then, as I said, other part of the code can just subscribe to the observable and do whatever they want with this information, react with this event.
Thank you. So another place where we use observables in TweetDeck is when we actually send a tweet, quite a crucial part of the application. And so here's how it works. So when a user enters the text into the input field to send a tweet, they go and they try and click on that tweet button down on the bottom right. And what we need to do is we need to watch for clicks on that tweet button and check whether or not the user should actually be able to send the tweet at that point in time. There's a couple of reasons why they might not be able to. Say, for example, they've entered too many characters, or say, for example, they have a setting in TweetDeck which means that they should tick a confirmation before they send the tweet. So here's how the code works. So we start by creating an observable from the clicks on that send tweet button. So if we were to look at the observable at this point, all we've got coming into our stream is every time a user clicks on that tweet button, we're going to have the event coming through the stream. And then we want to perform a side effect to stop the event from bubbling up the DOM. And then what we want to do is we want to go and get the latest value that's been emitted on another observable. So this other observable is called compose state. It's a bit of a weird name, but that observable contains the latest information as to whether or not the user at that particular point in time, at the point in time in which they've clicked on the tweet button, whether or not they can send the tweet. So compose state contains the information regarding to the character limit and the confirmation and everything that I mentioned before. So what we can do then is we can apply a filter operator, and again this is an RxJS filter, and this will mean that the values will only continue to flow down our stream if they pass this state.canSend over here on the right. So this will basically filter out any of the events where the user shouldn't be able to click the button or send the tweet at that point in time. And so then we can go ahead and subscribe to our observable and pass it the function, the send tweet function, which is going to be performed every time an event trickles down the stream.
Cool. So now you might think, why would I use RxJS? So let's go through some of the benefits of using RxJS in your code. The first one is about.
Oh,
oops.
Back.
Yeah, sorry.
Sorry, you're
not supposed to see that GIF just now. So the first thing is it makes it really easy to manage several type of event. When your app is just starting with very easy user interface, it's kind of easy to manage manually a couple of events. Events coming from the DOM, from the user interaction, from the server, etc. But as soon as your app starts to get more complex, then it can really be messy to react to all sorts of events coming in all sorts of different ways, and it's really hard to keep track of all the things that are going on the UI. So one of the things that RxJS does really well is it focuses on the data flow. So you focus on the data flow, so you know whenever events are happening, then you can combine them, you can filter them, you can do things, and then at the end of the line you can really update your UI accordingly. So it's a bit like this animated GIF, like the dog can cope with 1 ball, 2 balls, 3 balls, but at some point it's become absolutely unmanageable and it's just flooded in balls. So yeah, that's kind of good analogy I thought. The other thing is about memory. So let's say you've got a lot of information, of data to process. If your data is streamed, then you can just process one data at a time. You can take the data, process it, update your UI. You don't have to hold all of your data into the memory, and this, because you're going to only be acting on one memory at a time, one piece of data at a time, then it's going to be, in terms of performance and in terms of memory consumption, it's going to be much, much better. There is this really cool quote about Jafar Hussain again. He says, as the data comes in, it can be filtered. It doesn't get stored anywhere, it just gets passed on, and the data is like a hot potato, and nobody holds onto it. Okay, so I don't have a hot potato in my pocket this time. But yeah, essentially that's a very cool quote that illustrates the memory efficiency of using this pattern. But obviously, as any technical solution, it comes with downsides as well. So the first one is the mental model. It's quite hard to wrap your head around the concept of working with streams and working with data, because if you never came across this paradigm as a developer, the first time it's going to be really confusing, and it still catches now. But once you understand how it works, how the data flow works, and what you can do with it, it's actually really powerful. But so I would say the learning curve is quite steep to start with. The other thing is there's a potential risk of code bloat, because as we said before, there's tons of operators, and RxJS comes by default with many operators, but it's really rare that your application is going to use every single of them. It's a bit like when you use Lodash. You don't usually want to import all of Lodash in your code base. Usually just cherry pick the operator that you're actually using. And it's the same with RxJS. I think it's not something that you can do at this point. You have to import it. Can you?
You can, yeah, you can import.
Okay.
Yeah.
Cool. So make sure that you are careful with your build system when you use RxJS, and don't import code that end up not being used by the client.
Oh yeah, so we've put together a little list of resources for you, for anyone who's completely new to RxJS and wants to try it out and start learning. Head to this URL, and we've put together some of the resources that have been particularly useful for us. They'll be on the next slide too, so you'll have a moment to note that down.